Hey class, today we're going to look at the fourth gas law, which is Avogadro's law. Much like Avogadro's number, except much more simple. Now, Avogadro's law first states that a given volume of gas at equal temperatures and equal pressures will contain the exact same amount of molecules, regardless of what gas it is. Now, the formula for that is V1 over N1 equals V2 over N2. A direct relationship, just like Charles' law. In this case, V is for volume and N is for number of moles. Now, seeing as how we're using volume and moles, pressure and temperature are constant, so we don't have to worry about those. If you get pressure or temperature in a question, disregard it. It's just fluff, trying to get you to mess up. Now, again, first thing you want to do is identify your unknown. So in this case, let's read the question. Little Johnny adds 2.5 moles to a balloon that already contained 3.2 moles, which created a new volume of 13.5 liters. Based on this, what was the original volume? So, a couple of key words here, created and original. If you create something, it's new. If it's the original, it's old. So we created V2, we're going to be solving for V1, which is the original. So V1 is our unknown. Next up, you want to look at your three values you're given and plug them into your simple proportion. So first up, set up our proportion here, V1 over N1. Now, what is N1? 2.5 moles? 3.2 moles? Read the question very carefully. He added 2.5 moles to a balloon that already contained 3.2 moles. So the original value is 3.2. That created a volume of 13.5. Well, since that's the only volume we have, we're solving for V1, it has to be V2. Now, what's N2? It's 2.5. Wait. He added 2.5 moles, so we have to add as well. So 2.5 plus our original 3.2 gives us 5.7 moles for our N2. Now, since this is a direct relationship, if moles are going down, we know our V1 is going to be lower than 13.5. So now, cross multiply. Take 3.2 times 13.5, which gives you 43.2. And now we're going to divide that by 5.7. That gives us a long answer of 7.5789 4737. How many decimal points are we worried about? Our most precise measurement just has one. So we're going to round to that first place. All this other falls off. Round up, we end up with 7.6 liters of that gas. Just like Charles' law, except you don't have to do any temperature conversion since temperature is constant. So it actually saves you a step. Next up, the ideal gas law, and that's it for this chapter.